Yeah, thank you very much, Giovanni and Tim. I mean, yeah, thank you very much for the invitation. Like it's like the feeling of traveling while staying at home. So it's kind of cool. Yes, so I will. I have few slides, even though like I will mostly do demos. So I will talk about agile visualization and especially with Roassal. So I will show you like the work I did, but Roassal is, Roassal has been around for quite some time. So it's not only my work. So for example, like Milton Mamani and has helped me a lot on getting, where we are now. So before going into the talk, I just want to say a few words about myself and why actually I'm here presenting. So I am professor at the University of Chile, so in Chile, and besides teaching, I do a lot of research. I do research in software quality, and that is a very large umbrella. And one of the things that really interests me is memory consumption, software testing, CPU consumption, resource consumption. So those are the things that that really interest me. So yeah, so me and my group, we are really getting up every morning, and work on trying to improve, the world by producing techniques to, to make software more reliable and more secure and faster and consume less memory. So the range of applications I'm really interested is very large, very broad. Recently, I've been focusing on flight software and robotics behavior. So flight software, this is a software that is put within a flying thing, such as a satellite. So the Chile has now a satellite up in the air, and I've been working on that. And I will say a few words about that. And also, like, I'm interested very much in robotics, making sure that software put in robots, behave the way it should behave. This is also something where I am involved very much. So, as you know, producing software is really hard, and it's really hard. And something that we have discovered is that there are some tasks where artificial intelligence and visualization techniques can really help. So today I will talk about visualization. So I will leave the artificial intelligence part for another talk. I had to decide which one to present, but I'm interested very much in artificial intelligence techniques. I will say a few words maybe at the end about that, but I will talk about visualization. So why I decided like to present here at to you. I am, me and my group, we are really looking for opportunities to apply your research. And like in academia, applying techniques, thinking about solving problems in some toy example is something that is very common. But something me and my group, we have been really trying is really to bridge the gap between academia and industry. So which is why I'm always very interested in talking to you and talking to companies and understanding really the problem that people have. So yes, so AI and visualization. So this, some of my ideas were put in books. So there is agile visualization. So this is this book here, like it's maybe a bit old. I think it was in 2016 that I published it. So a second edition is coming. So I will talk more about that. And a few, like 2 months ago, there were this artificial intelligence, agile artificial intelligence book that went out. You can, you can really interrupt me whenever you want. You can I can read the chat. So if you have any questions, you can just write in the chat. Or you can even raise your hand or whatever. Okay. So okay. So I will essentially be based on demos. So I will do plenty of demos. Okay, so here this is the Faro 9, and I will just start to type things. again, if you have any question, if there are things where you think I should say a bit more, then please let me know. So here I will. So Roassal is a visualization engine that works for Faro. The Roassal3 works for Faro, and Roassal2, the previous version of Roassal, works in VisualWorks and Faro. I know actually some people I've been putting some effort in migrating Roassal3 to Squeak. I don't know. I'm curious to see how we might go. So demos. So here I will just draw some numbers. So here, this is a small script that's open a Mondrian. Mondrian is a particular API to actually high-level API to easily build script. And so here I've asked Mondrian, please show me 5 numbers, ranging from 1 to 5. And here I have my numbers. Here I have 1, I can drag it. I have 2 here, and 3 and 4, and I can have plenty of numbers. I can have more numbers. And here I have 500 numbers. So all the numbers look the same, right? But I can say maybe that the size of a number actually reflect the number itself, because here, like, all the small square here are the same. Maybe I can say, oh, like, I want that. So I want that the size, oops. And here I have, like the 500 here is large one, and here the 1 is very little. It's very little here, the 1. And yes, so this shows you a bit the feeling that one might have in programming in Roassal. So here I have this playground where I can type things and I execute, and I have immediately the visualization that is around telling me like how the script is going. So this is something that the Faro programming environment can give me for free. And like, okay, I will do that again. And here I can change, instead of having boxes, I can have circles, and I can also change the color of the circles. Oops. So here, like, each circle here is a number. So when I want to decide the color of the circle, then I have here a number that I can do whatever I want with that. I can say, for example, if the number is odd, then I want to have a color red, else it will be, let's say, gray. And here I have 499, which is odd, then it is red. Also, I can draw some lines between those numbers. I can say, here I have a line that I want to connect those lines from, the number divided by 2. So here for example, here I have the number 500 that is connected. Okay, so I can look above, where is it, but it is connected to 255, the 500 divided by 2. Now, also, I can change the layout, can use the layout such as a tree. Oops, or maybe the cluster here. So I have a number of layouts here that we can use, radial, cluster, and so on. So, okay, so this is, the essence of Roassal. I can write script where I can manipulate objects, and I immediately see the feedback, see the result of it. So this is, playing with numbers is kind of hello words. I will not go much further in playing with numbers. I will use here an example that I've been working recently for NASA. So NASA, they built software satellites, and I did some analysis of their software. So I will use exactly the same script that I have. So here, this is the numbers. Okay, so here I have my 5 numbers. Okay, oops. Here I have to speak here. Okay, so here those are my 5 numbers. So now here, instead of having here the numbers, I will use some units of the flight software that has been produced by NASA. So so NASA has written a flight software, which is a software that is put on a satellite, and the satellite, to behave the way it should behave. And the satellite is the software is written in C and C++ and some other weird languages. Okay, so instead of having here numbers, I have a module, unit, a module, we can say that. So a module here, which is, I don't know, I think you should see here where the pop-up is. Here, the mouse is pointing at the tester base.cpp. And yeah, so here I'm visualizing C++ code. And, and then there are plenty of things I can do. I can say, oh, why not to have, why not to have a shape here, or let's say a box. I want to have a box, and I have, no, maybe like this. So here I will normalize, I will give a size to each box. I will here normalize size, and I will say here number of lines of code. And then now you see that the size of each box is changing, because I can directly ask for its size of code and use this information to actually impact the size of the unit. So here, I will click on the first one. Here, this is com.logger.cpp. I can click on it here, boom, and I see here the source code. So by the way, this is software that's been produced for NASA, but this is released under open source. This is open source software, so I'm not doing something illegal like showing you here the code. And so here I can, I can ask self number of lines of code, which simply actually count the number of lines these files here, com.logger.cpp has. That's all. So I'm mixing here the visualization with actually like modeling the software source code. Are we not going to details about how I model the software source code? I could talk about that. If you have any question, please ask me. But this is yeah. So I have a way to actually reify everything from the source code and be able to display that on the screen. So yes, and and here I can add some. Yeah, maybe I can, yeah, a funny example here. So is, okay, so here I can click on some files. I can browse the file that way. So you see here there is this kind of header here with, I can click here. Here there is no header, Time to time here there is something about copyright. So here, for example, you see that there is a copyright. So the copyright here is specified. Okay, even though it says that, but this is open source. The author of this code told me that. The group who made the code told me that. So you see that here again there is copyright, but here I think there is no. Here there is no word copyright mentioned. So maybe I can, like as a very simple example, I can start to highlight, whether some words, whether the word copyright appears. So I can, again, I can redefine the color of my box. And here I have a module, and simply I would say that, if maybe copyright, no need to, maybe to put the C, to not have the big C, the small c, and then if I have a match here with the M source code, and if this is true, here I have a color green. If this is false, I have a color gray. Boom. And then, all the green, this is where there is the word copyright, where I have something, saying about the copyright here. And the gray, where there is no copyright, no mention of the copyright. Here there is the author, but here there is nothing. So again, I'm not saying this is good or bad, not at all. I'm not saying this is good or bad, but this is just something I see. I do not fully understand the software, so there is, but that was something easy that I could easily see. And yeah, and here I can also have some lines, connect to all. Here I have outgoing units. So now I can see here the dependencies between those units, those modules. Actually, here is modules, which is a CPP, and a header, which is a HPP. You know, so I have and a module and a unit is a module and a header is a unit. And yes, so this is what I have. You know, I can change the layout maybe. Maybe here I can have the force layout. Force. Oops, maybe I can have something like translucent. Maybe I can also put a bit more repulsion, but this is just a again, this is just a simple example here I'm showing. So and if I do like charge -300. So again, this is, you know, like I'm playing with the data pretty much the same way I did with the numbers, and this is something like that was very important for Roassal, to be able to deal with object in general and to have a very good abstraction mechanism to actually play with the object. And the object could be very simple one, such as the numbers. It could be a complex one, such as, you know, source code. And yes, so here you see that there is some, you know, some files that actually hubs, you know, like this asset HPP. And yes, so apparently there is plenty of assets everywhere in the code. Is there any question here? Like, if you have, please. Okay, so that way we build some visualization that I presented to Neza some times ago. So here, this is the architectures of the software here. So this is, so I built that visualization very much the same way that I show you now. Okay, so I did it in a very incremental way. And so here, this is a big gray box here. This is a layer, you know. So here I have DRV, which is the drivers, and here I have something like about the OS, you know. And here I have, you know, SVC. I don't know what is SVC about. And here I have things about encoder. So, and inside I have the source code, the files that belong to that layer. I can click here, you know, and I see the source code of it. Again, this is a very simple. This is a very simple visualization here. I'm currently working on improving it and showing, for example, dependencies within modules and so on. And here I have those edges. You know, those edges. This is that shows the dependency between the amount of incoming and outgoing dependency. For example, here I see that FW, which is a very low level framework, you see that the SVC is using a lot of FW because here is very thick, but here like FW is very thin. So FW doesn't use a lot SVC, but SVC use a lot. Depends a lot on FW. And I have the OS also that use a lot this one here. This one use a lot this one. So this is a very handy visualization to actually show the architectures. I'm reading the questions here. Yes, so G toolkits. No, Roassal is not really part of G toolkit. No, not at all. We were discussing whether, in theory, it could be possible to mix these two, but currently it's not. G toolkit, the philosophy I understand is a bit different in the sense that I have one single rendering tree, and everything is homogeneous in the way they can be handled. In Roassal, we do not have that property. We could, but we haven't yet. And yeah, so here John is asking what other layouts are available for us to play with. Actually, there are few layouts. So I like that when you ask questions, you know, I can. So here I have Roassal. Oops. I have Roassal here, and I have the package layout, and I have, all the layouts that can be used. The cell, the grids, the radial, the dominance, plenty of things. And also here we have something about the graph. Oh, sorry, graph. Oops, I haven't loaded here. But we do have a bridge between Graviz and Roassal. So Graviz, for the one who doesn't know, for the one who doesn't know, who don't know, Graviz is the state-of-the-art layout. And this is written in, I think, in C++. And we have a bridge to use Graviz layout within Roassal. And this is actually pretty cool, because also we can also use the control point that give us a Graviz. I haven't thought about doing the demo now. I need to load Graviz and OS to process, which may take a couple of maybe minutes, so that I don't want to bother you with that. But yes, so we have plenty of layouts, and we can even have more, such as the one of Graviz. Graviz has plenty of layouts. I'm reading the question here, so please bear with me. Alfonso is asking, what coding patterns have you observed that have the most impact on software quality, and how do you visualize it? So this is a very broad question. There is no one single answer. At the end of the, after that demo, I will show you some of the results we have had so far. And yeah, so this is a very broad question. There is not just one solution here, one answer. But I will give you plenty of examples. So an integration with Seaside on the rendering the images and sending them to browser. I think some people have been using Roassal with Seaside. So we do have some. Where is my browser here? So so here we have the Roassal3 exporter. So we have some fancy way to export visualization. Here you see the visualization within Faro. Like we are using Athens, which use as a backend Cairo. So we are basically using Cairo to actually render Roassal. But we have some number of others exporters. So if you load, you can access those exporters by executing that. We have PNG, we have SVG, which is very handy to embed that within the web pages, for example. We also have PDF, and also we have like videos, MP4 or MOV. This is very so. Roassal has plenty of animations that I can. I will give you a couple of examples here, and you can really use that. For example, like if you want to have the PDF exporter, is that way. If you want to have the video, then you need to have, so here you have the animation here, and you just say, okay, video exporter, then please export during 2 seconds to that files, MP4. And also here we have something very cool, which is A-Frame. So A-Frame, this is libraries to actually that is used very much in virtual reality and augmented reality. This is something also I'm very much interested in. So exporting the visualization, the Roassal visualization to to augmented and virtual realities. I won't talk much about that, even though I do believe this is something that will really be very important in the future. Okay, so plenty of questions. Oh, thanks. I love questions. So I will try to answer a couple of them before continuing. What tools? Is there integration existing or plan to plant UML? No, unfortunately not. Could be interesting. This is a question that people have asked me already. Something that we did for so we have Roassal that is embedded in Faro, as I told you, as I'm showing. But you can click here and you have this UML package that appears. I can here and here I see the UML class diagram. So here this is an example here. Now another one, and Yes, so you can have this the UML class diagram, and I think you can click on, and then you have here the source code. I have a very small screen, but if you have a larger screen, that makes much more sense, where you see all the code. Also, you can, if you select a class here, you have UML class, and yeah, this one has moved because I clicked on inspectable example. If I click here, it's moving again. So this is very handy when I have complex class hierarchies, and you can see what is. So maybe in that case, yeah, so here the class, for example, has subclasses. If I go here, then you can see some. Yeah, and here you see all the subclasses of as object with property. I'm currently visualizing Roassal using Roassal. Someone asking what tools are you using to load the object being visualized for the source examples. So in that case, like for that code here, this is I have the C++ code, and the C++ code has the source code has been transformed into XML. So I've been using an academic tool called Source ML, SRC-ML, that actually transform the source code into XMLs. And then I'm just processing some XMLs here. Someone asking also, what is the relationship between Roassal3, which is this one here in 2D, and which is already included in Pyro 9, and the work on Roassal 3D. So there's been some we did some work on having Roassal for 3D. Yes, so this is something that we did several prototypes, and things were going extremely well. We plan to continue to work on that. But the problem with 3D, whenever you deal with 3D, you are facing some extremely technical topic that make things, not so nice. For like there is OpenGL, now the world is moving to Vulkan, so we need to migrate everything, like from OpenGL to Vulkan. So that is a problem, but not a big one. But the bigger problem is to make sure that it works on Mac, on Linux, on Windows, and that is where things are getting complex. So something we are currently focusing on is using A-Frame to actually have 3D, virtual reality, and augmented reality. Yes. So okay, so so that was a very simple examples where I can show you like a kind of sophisticated graph, but we have plenty of visualization here. We have, I assume here I have this, some values here. I have some numbers, let's say it's 1, 1, 4, 5, 10. I have some numbers here. I can draw some graph. I can chart. I can build a chart with those numbers. That's very easy. I can do chart here. And here I need to have a line plot. So I can use the line plot. If various plot exists, I will show another one now. And here I have the values here. As the y, I want to have the values. And now I need to add that plot here to the chart. And then I open it. Look here, this is my chart. Okay. So, well, I mean, I can add some decoration to it. For example, I can say add decoration, where I can have, RS horizontal tick. And I can add the ticks. Similarly, I can have like the vertical one. Oh, here I have the vertical ticks. So you see that he has moved a bit, right? Now, for example, if I do that here, then this one here goes here. If I do that here, if I add this one here, it adds some space. You see? And the reason for that is that there is a sophisticated algorithm behind that is trying to compute what are the right the right extreme and the right labels for the ticks. According to the number of ticks here, there is an algorithm that say, which one is the most, is the most pleasant to read. So it doesn't seem to be a big deal, but actually it is. So whenever you try to build a chat like that, then you will spend, quite some effort and actually identifying like which value I want to have as on the Y and X axis. And he's asking like, is there a way to make the chart dynamic? When I want to add a value to that chart, things I don't know. Maybe there is. Let's check. Dynamic chart. But I don't know. Let's look at some example. Okay, we'll have a look whether we can have some dynamic charts. I don't know. We had that in Roassal2 and Roassal3, maybe. I don't know. So I can have here like any values. So let's say here I have some classes, and I have all the collection with the subclasses, with all subclasses here. I can have the X, which is the classes collect number of methods, and the Y, which is classes collect number of lines of code. Again, those are some methods that are defined on the class in Pharo. So so basically I will plot that. So maybe I want to have here a scatter plot. Okay, I have the scatter plot here, and I have the X, which is the X, and the Y, which is the Y. Open once, and this is what I have. You see, like the thing I was telling you before, like identifying the range of the value that should be displayed here, is 0 to 400. You don't want to have, you don't want that to have like 380 as the maximum, right? You want to have 400 here, is more pleasant, such as like 3000 here, right? You don't want to have 2783, for example. So there is an algorithm behind that has some heuristics to identify what is really the right, the most pleasant one. And again, there's plenty of things you can do, such as L color blue trans, and I can have some, I can combine plots. Here I have classes 2, let's say LRS objects. So this is Roassal, now since the standard collection libraries, and here this is the class 2 here, and I have another plot here, and I say red maybe. Red, and here I have 2, and here I have 2. Let's say that should work, I guess. And at red I have the Roassal classes, and the blue, this is the collection classes. So this shows a bit like what is the correlation between the number of lines of code and number of methods. So I guess that the method are a bit here. Those are utility classes here. Yes, someone is asking like whether there is the log scale. Yes, there is log scale here, and there is log scale, and I was thinking maybe of showing, maybe I could show some COVID-related thing, but maybe not. And here, and you see, the log scales. I have plenty of you can define your own scale if you want to have. Maybe because you want to have some linear part in some portion, some logarithmic on some other one, or square root. You can really build your own scales. We have a nice class hierarchy for that. And I'm reading here the John were asking whether there is a time-based visualization, day of months, time of day. No, I don't really have an example here, or I don't know. We will look in the example, and maybe there is one. Yes, so the trend line. So let's look at the examples here. So I have the chart example here. I have the, I can have plenty of markers here. So I can click here, I can open. I can define my own markers if I want to have. And again, it's very easy. You know, I have this Y marker declaration where here I want to have maybe like the average. I think, yeah, so that one here, average, you know, this is what actually it does. And I guess here I can do something like the color, right? Yeah, so here I can have like the average. You can build your own if you want. You can build your own markers. So yes, we do have markers. So here there's nearby scatter plot. You know, you can also have labels. Something I did. Yeah, you can have labels here. You can see. Yes, so Randy is asking whether we can have some bit of interaction. Of course, we can have that. So I think that if we do that here, and no, here and that examples, no. I don't know. Let's look whether there is an example that shows that. But yes, so being able to click and have some pop-up or some opening an expector is, yes, we can do it. It's just that I don't know. Let's see whether there is an example that shows that. I mean, there are plenty of things, right? I mean, I do, maybe there is no need to go over, you know, all the. There's something interesting here, you know, like here there is no, you know, I never talk about colors here. So this graph here is the result of executing that. You know, there is nothing about colors. So the charter like is picking some colors from a set of palettes. So you can, you know, it's a bit like what matplotlib is doing in this in Python. You know, you can have number of ticks if you want to have very few ticks or plenty of ticks. Font size, you know, you can have big titles that could be very handy. Or yeah, so you can have like some, you know, you can combine those yes. So here this is transformation bar plots. Yes, so here we have some bar plots. And we can combine, you know, if you want to have some lines on the top of a bar plot, you can also, yes, yeah, kind of handy. So this means that we are doing that by actually setting the size, you know. Yeah, don't want to go into details, but basically you can set the size, and I want the size and the color to actually, you know, using a normalizer to actually reflect some metrics that I want to have here. Yes, and I can have some fancy things such as this one, you know, with the area. This one here, for example, is also computing some errors. Also, something interesting we recently added is some space here, you know, because sometimes you don't want really the lines or the dot to be on the lines. You want them to be a bit inside, right? Again, this is just to make things more visually appealing. And yes, you can have some lines that use some weird style of the lines. Yeah, you can have some series and some, you know, when things are overlapping, and you can plenty of things. This is the, yeah, this is the so yeah, so there were a question about the you know, about the time. So here this is an example of the times, you know, and here we also have the gradient, you know, like it's going from red, from green to white. I'm not saying this is the best choice to design such a graph, but this is what instead I want to show is that we can do it. We can do it. And so we do have a bit of animation. There were a question about like dynamic things. So here we have one. And animation actually is you know, I will show you some of the animation because Milton also, yeah, we have those. Yeah, I'm gonna have a grid. And also recently we did some you know, two bars, and when you put the mouse here, you know, you have the value, and when you put the mouse above, color is changing. So that answers some of the question that were, but yeah, so we have the horizontal chart, you know, and here we simply have the value. And yeah, we can have some patterns, you know, for the bars. Again, I'm not saying this is good practice to actually use them, but this is just to show that we can do it. Yes, we have that, and we also have a way to build legend. You know, like here, legend. You know, that we have actually a builder. I can build a legend. Okay, and I think that if I do, you know, like I can have like the legend on demand. Oops, here LP. on the end. So if I do that now here, I have the same thing, but the legend here is not there, right? But instead, you know, it is here. Again, you know, not a big deal, but we did that. And yeah, and so we have a bit of animation here again. So we have a sophisticated way to build animations that I will, I think, briefly give an examples on animations. Oops. Yeah, so here someone is people ask me to show that, so I'm showing that. Yeah, so we do have some animation here. So I can show you a couple of things and how it is made. So we have, okay, so here this is to actually build the next normalization. Here we have something where we can, so we have a pie builder where we can actually build a pie, but we hooked into the way that the pie should be built by using some easing, which is a way to make the bouncing effect, you know, that you are currently seeing here on the visualization. And yes, so yeah, here the pie example. I didn't think about showing that, but you know, I can have plenty, you know, yeah. So Milton is an artist, so he likes to, he likes animations and yeah, you can have some space, you know, like for the pie, and yeah, you can have some colors. Yeah, here, you know, you have those things here. Yeah, I don't know. I mean, there are really plenty of examples. I don't know whether there is no point, I think, in going to all of them, but tick animation maybe here. You see here is bouncing again, and so we have so the animation actually comes from this one is cool. See, it's kind of organic thing where, you know, yeah, someone is asking whether there is what about the interaction, whether there is a part of the visualization I can click on it and update it. Yes, I don't really have a demonstration here, but yes, so this is something very, very important. So it's not really, so yes, we can do it. Animations, you know, visualization can get really updated, and you can really do some exploration. So yes, this is something we're really spending some time on that. So yeah, I mean, my day. Yeah, so this is, you know, you can have some labels here that are correctly rotated, you know. I don't know. You see here again, this is kind of toy examples to see whether we can have some controls for something. You know, and here when I'm moving here the mouse, things get updated. Many pies, you know, you can compose them. I can also apply some transformation here. So here I have the blue because this is for debugging mode. Yeah, so I show that. Rotated animation here maybe. Again, I'm not saying this is the best way to show data, right? Instead, there was a cool examples that shows that we can do it. You know, you see like where the words gets, you know, always at the center, where there is no confusion, where the label that here actually is showing many pies. You know, I think here they don't use that one. Yeah, you know, again, another way where you can yeah, so here someone asked me for that thing. Yeah, so this again, simple examples that shows how I can actually interact with some object, because when I clicked, then I remove, it's not draggable anymore. Yeah. So yeah, it's simple, simple examples. I don't know, maybe like some SVG, maybe SVG example here. SVG shape. So here I've got one here. Okay, so here this is SVG, and here they took. This is really SVG. Drag and drop. This is really SVG. And SVG animation here. I have plenty of icons. And here the Miku, this is, yes. So because here we have like one SVG, and then we can extract different subpart of the SVG, and when shuffling them, and then we are putting them back on the, I don't know. So this is the new icons of Roassal. Yes, so flattening the curve. And yes, and here we have, all the content of the SVG. Again, for the animation here, we simply apply some transformation to the thing. I don't know. I mean, there are so many examples here. Animation. There are so many examples about animations that, wow. I mean, yeah. I don't know how you see it, but here this is extremely fluid. And here you have this small graph here that gets updated. For example, here it's going fast. It's like 40 frames per second. If I try to move things, it gets in slower. Of course, it gets slower. I can rotate here. Yes, you can change dynamically some shapes. I don't know. Yeah. I don't know. So you see here is bouncing back, right? Because we use the easing. Here I'm kind of drawing, and then there is this effect where they use some noise generation to actually apply some deviation in trajectory. Yeah, I mean, there are really plenty of examples. It's beautiful, this one as well. So I think, plenty of examples actually come from D3. We pick some, D3 is a popular framework. It's like Roassal, but for JavaScript. I believe there are several things we are doing better. This is extremely fine, finely designed visualization here. Yes, I don't know, plenty of them, plenty of animations here. You can compose animations. We have, a particular, I don't know what this one. It's here there is a problem with the fonts because I don't have the right fonts here. Yeah, this one is kind of, yeah. So here, this is one layout where we have the force-based layout, but if you give more space, then it gets, then if you give little space, then you can start to squeeze it, right? It's kind of, there are really many examples, and plenty of examples are pretty artistic. I think this one is one of them. Yes, this, I don't know. I find that I like to draw, so I think it's getting. So I'm looking now at the questions. So someone is asking where we use Graviz, what is the motivation or use cases that drove the integration of Graviz. So all the layout that I've shown you now are built in pure Faro, in pure Smalltalk. The layouts here are in pure Smalltalk, and that works well. And this is very convenient to have the layout built in Smalltalk. You know, like it's portable, it works well, but it does. You know, the layout do not scale well. I mean, you know, a couple of thousands, you know, hundreds of thousands object works well. For example, like usually when I have, it happens to me that I want to do a force-based layout over hundreds of thousands of objects, and I leave the computer for a couple of hours. But something that and this motivates really to use Graviz. Graviz is extremely, you know, optimized. You know, it really works well. And then if I have like plenty of objects on which I want to do layout, then I simply use Graviz. This is the motivation to have scalable layouts. Yes. So is someone is asking like which minimal protocols that the nodes in Mondrian have to implement and the link. Well, I mean, there is no minimal protocol. It has to be any object. Really, like I don't know, like if I have Mondrian node new here, and I have the nodes, I don't know, a color, red, number 42, yellow, oh, and boom, oops. Okay, so here this is my tree object, right? I do not say how I want to, but basically I can render any object. I can click on it, and then here I have, you know, the object 42 here. So yes, so there is no minimal things that one should have. Is there like does it take advantage of the GPU? No, that I don't think so. I don't think it could, but I don't think so. So whenever you start to, so I don't think Akero does it like by default. We are currently working on integrating Roassal3 and Wooden for the 2D engine. In that case, it will use the GPU, but currently we are not really taking advantage of it. Yes, so this is like more or less what I wanted to show you at the core of the maybe here a couple of examples, but yeah, I mean I can have this I think here this one is kind of pretty here. Like I can have those edges here. So this is, yeah, you know, you can do that, you know, you can rotate that thing here. You know, that there are several ways where you can, again, this is useful to show hierarchical things, hierarchical properties. And I think here, this one here, I can click on one, you know, I can exploit, I can, you know, I won't. So, well, okay, question. Can I show a PDF output? Yes, let's, I don't know, like I take an example here of that one, for example, here. But I don't think I have the PDF exporter. I don't have the PDF exporter installed. Well, I mean, we need to. Yeah, I don't have the PDF exporter like here installed. I didn't expect I would have such question, but basically it works. I mean, it works well. I mean, we've been using the PDF exporting for the PDF exporter for large companies in California. So, and we are producing multi-pages, you know, where pages, I have plenty of graphs, you know, to indicate about software quality. And so, yes, I mean, the PDF exporter works well. I mean, we use it a lot. And about the wide examples, like there's something you load, I loaded on top of Faro 9. Well, I mean, if you take Paro 9, you will not have the examples because you need to load them from, you need to load the full version of Roassal, because in Paro 9, you just have the minimal, the core, just to be able to do some UML drawing things. But you just need to execute that, and you will have really all the examples here I'll show you. Yeah, this one actually is kind of cool. Here I can, and I don't know what it does. I think those are classes again. So here this shows some architecture of some software. Yes, someone is saying that, yeah, we use that in graphics that has already a PDF exporter. Exactly. Yes, exactly. Okay. I think this is what I wanted to show you with maybe another examples here is a tool that we built with, which is Pi, and this is a profiling tool. So we've been using the profiling tool that monitors the execution of software with the visualization. So here, for example, we have APAO, which is a test coverage tool. So here we can, let's say I want to know the coverage of the class RS canvas. I can click here. I'm running the test that actually tests the class RS canvas. And here I see this is the test coverage. So here there is a problem with the fonts. There is a problem with the fonts because this is Paro 8 and Paro 9 will not happen. Just need to load that in Paro 9. But here this is the class RS canvas where each small square here is a method, and in the size of the method indicates the cyclomatic complexity. You know, like the 8th is no, it's not cyclomatic complexity. It is the number of lines of code. So the 8 indicates the lines of code. You know, so I click here and I see this is. Oops, I don't know. I don't know what happens, but well, I mean, it is a tall method. I don't know. I click here. Whoa, I don't know what happens here. Anyway, so this is a way to visualize the test coverage. So the size of the method indicates how well it's covered. The width, you know, the width, it means that plenty of methods are coding it. So you see that the method here, plenty of the method are coding it. When I put the mouse above, you see that there is a small animation here with the edges. This indicates that. And does Roassal provide anything like Code City? So Roassal itself, no, but we did something with, we did Code City. I will show you some examples in a minute. I'm just looking at whether there are some other questions here. Yes, so someone is asking like any tips for picking ways to visualize things. You know, someone is saying that I always struggles, and you guys seems to find good ways to show things. Yes, designing a visualization is complex. It is pretty complex. It is much more complex than one can think. You know, like you know, whether we should encode the property into color or the size. You know, which kind of interaction we should have. So this is something where this is not easy at all. This is not easy at all. So we do have plenty of experience with that, but this is not easy at all. Yes, someone is asking. Yes, we do have integration with. We do have integration with. We do have integration with Spec too. You know, so here this is a small spec interface where I can, you know, draw this, but here I can have, you know, blue here, and this is kind of, you know, this is a way where I can take a script, execute it. So this is more an example of how the integration with Spec 2. Yes, Spec 2 is very important because one day we will move to native UI in Faro and Roassal should work. Okay, so I think this is what I wanted to show you with the demo. I will give you like some case study that we did and how we applied Roassal. So here, this is the F prime. This is the flight software. This is the flight software visualization we did for NASA, where you see the architecture of the software. You can click something I didn't show, but you can click here and boom, you see here the interaction, and each circle here is a files, and you can click here and you have the source code. Yes, and here this is the visualization of the satellite flight software that we have here at the University of Chile. So we have each big box is a file, and you see dependency between the files, and the color indicates the architectures, and this is where you may spot some dependency that you do not want, such as those one here, for example. Those files here use that files, and they should not. So thanks to the visualization, it was really easy to spot this problem here. This one indicates the difference of performances. In our research, we're interested in understanding what makes the software slower or what makes the software faster. We built a visualization that shows the difference between the call graph, and you see that, for example, this method here in red, this is a strong red. It means that the method here has been modified and it is slower. This one as well, it has been modified and it is slower. And if you put the mouse above, you see that it is 23% slower. Yes, we are doing a lot of experiments with augmented reality and virtual reality. So here we have an example of a code city that we built using Boden and Roassal3. So the vision behind this effort is why my workspace is restricted to the screen of my laptop. You know, here, for example, I have two screens, right? But why two screens? Why I cannot project something on my wall and something on my desk? You know, I have plenty of space on my desk. Why I cannot use that resources, which is the space on my desk, to actually show something? And this is what here we did in that experiment, where we have the code city. The application is being run here. The application is running here, and you see, like in red, the class that is taking times. And here we have a dashboard where things are showing. So we have been using HoloLens for that, HoloLens 1. Here another thing that shows the memory consumption of a calling context tree. So each large square here is a method. So you see, you know, what the method are being called and what are calling. And inside the inner squares are the classes that has been instantiated by that method here. You see, for example, the method D instantiates a lot of circles, because here this is circles, because this is a large square, so it's instantiating a lot of circles. It's instantiating a few boxes here, and here in that branch here D is instantiating both circles and boxes here. So this one I already show you. This is the up arrow things, where I can show the class hierarchies. So we did some experiment on visualizing high performance computing. So this is something we did with the national laboratory in the US, where they've been running some very heavy simulation on a cluster of CPUs, and we are showing the difference between the call graph that is occurring, because this is the same computation being run on all the CPUs, and we're looking at what are the differences between, you know, the execution of those CPUs. And this is what here we are showing. So work that has been done in collaboration with people from the Livermore National Laboratory. And here, this is the Android application. So we are basically visualizing Android application. You know, we are, you know, how the visualization can help us to understand better, like to comprehend the application. And so here, I think this is K9, which is so we are visualizing the K9 application, which is the main client on Android. And we have plenty of properties that I won't go into details, but here there is a paper that talks about that. See, yes, at the top right corner, there is a paper, a full paper that's been accepted and peer reviewed. You can really have a look at it, and on my webpage, also they are accessible from it. And so I said that I will talk a bit about artificial intelligence, and here this is where it comes. We've been working on generating unit tests. So the idea is we are using some artificial intelligence techniques. In that case, this is genetic algorithm. We're using genetic algorithm to actually generate test cases. But the evolution process that the genetic algorithm is enforcing, is doing, is pretty complex. You know, like generating unit tests is not easy. And the genetic algorithm is a complex algorithm that is producing something complex. So everything is complex, producing other things extremely complex. So we build a visualization that help us understanding what's going on, like what is the evolution process that the genetic algorithm is taking to actually generate test cases. So we build that visualization here, and so it reads from top to down. So here, this is the generation. Each individual, each square here, this is an individual that is contributing to the final solution. And inside, I see the method that has been tested. So yes, but again, we have a nice description of that. I'm now reading some of the question here. I don't really understand the question. So if in your research, do we find that the dynamic nature of Smalltalk and Roassal is competing just use case or over other tools? No, this is central. I mean, agile artificial intelligence is really taking, I mean, agile visualization is really based on the dynamic nature of Smalltalk. The fact that I have the playground, I can do something, and boom, here showing this is central. And
how does it compare to like? How does it compare to like the JavaScript tools and some of the other things? I mean, there's a lot of visualization tools. I'm just wondering, you seem to get called into lots of areas. Is it, secret sauce? Is this something that people are really noticing?
Yes, so it is true that the generating visualization using D3, for example, it is extremely popular. Like most of the graphics you will see, for example, like in online magazine, online newspapers, where you see all these graphs showing an evolution. Most of them are using D3. The D3 is really cool, really. And but the difference between Roassal and D3 is that Roassal lives in the same environment, that the data. So the data are being consumed and generated within Smalltalk, and then are being consumed by Roassal. And that changes completely the way that you approach data and you manipulate data. In the sense that here, I'm not visualizing, like in the example that I show you with the flight software, I'm not visualizing yeah, I mean, it's not that I'm just visualizing some CSV file, as in D3 will do. You can really interact with the code. You can really interact. You have this object you can really talk to, and that changes completely the way, because like usually you have the server on the server side that is producing the visualization, and you have the client, that's on the web server where you have the D3 thing. But then you cannot really talk to the object on the server. So you need to serialize, and this is complex. But you have that for free in Faro or in Smalltalk, and that changes completely the way you can approach that, because you can, for any object, you can start to script things, and that is really changing the feeling a lot.
Okay, so, yeah. I guess I'm trying to grapple with that one and understand. Obviously, instinctively, the crowd here understands that, but I'm just trying to see how that translates with the visualization. I suppose I haven't used D3 enough. I've seen some fancy examples and thought, oh, those look really cool. And equally, don't get me wrong, the Roassal ones look cool. But it seems like you keep getting called into like interesting places that you're doing work, and obviously people have recognized that you're able to do more things than perhaps people are able to do with these libraries, and I'm just intrigued by that and fascinated, actually.
So for example, here, this one, okay. So here, this is this one here. I can okay. So here I can click on a file here, and here I'm clicking on a layer, and now, okay. So this is a large layer, and here on the layer, I can like here I have the visualization. So here I show all the units that belongs to the layer. I can click on it here, and then I can really see the source code. That doesn't seem like a big deal, but because everything here is live. I'm just visualizing a graph of object that exists in the memory of Faro, in Faro. If you would like to have the same thing in D3, then basically your web page needs to have everything.
Right.
Everything,
Yes.
everything needs to be like, and the application is large, right? The application is large. I mean, it's pretty large, and so you will need to load everything in the web browser. And this is what people in D3 actually that are struggling, because you don't want to load everything. So now you want to start like to just load the thing that you need to actually, to visualize things. If you click on something, then it gets loaded. But then this is extremely complex to do that. But in my case, in the case of Roassal, I don't need to care about that. And that changes completely the speed you can have in order to produce things.
Right. Okay. No, that's neat.
All these very low level technical things I don't have to care about, because
we just take advantage of them. We've forgotten. Yeah. Okay. Nice. Nice.
And that is really, I think, a game changer, right? I mean, the fact that that everything shares the same memory space, you usually have the data. I mean, here, like I can talk to my data. I mean, this is an object I can talk to, right? I can evaluate code on that. In JavaScript, you cannot do that, because basically you will have not an object, you will have some data, some raw data, but it won't be a class. I mean, you could, but it's not the way that people are dealing with D3. You can make some nice visualization, but click on something and start to talk to that object you just clicked on, that is really a different game. And this is where I think agile visualization comes into
You've ended up with some JSON, and then you can't sort of hide the complexity of that in an object that just answers things for you that you find convenient. Yeah. No, it's nice.
Yeah. And yes, so, well, I mean, this is what I wanted to show you. Basically, I thank you very much for your question and your comments. You helped me a lot, you guys, to drive the presentation. So currently, like we've been working on Roassal for more than a decade. Currently, we are incorporating feedback from users. Roassal3 is now part of Faro 9. It means that we got plenty of feedbacks, which is cool. We're currently working on a new edition of the Agile visualization book. So I'm writing, the night and the weekend on that. And also something that we are planning to work on at some point is to have a scriptless visualization engine. To have something built on top of Roassal on which you will not have to script things. So from all the experience we have had so far, scripting is something that people do not really, scripting, it would be great if there is a way to not script things, especially if you want to target people who are not people from Smalltalk. So we have a couple of ideas on how to have something which is scripting less, and yes, so something we're currently working on. Okay, so
just
thank you.
Just put in
very much. But yes, if you have a question.
Just put the scripting in an Excel sheet, then they will figure it out.
Yes, yeah, could be. But people in biology, they like to click. They prefer to click on things. People in biology or people in chemistry, for example, that we have been people also from physics, because in the satellite world and there are plenty of people with very little computer science knowledge. So asking them to write something could be complex. But yes, I. Okay, so the statute of documentation for Roassal3. Yes, documentation now is very scarce. I mean, there is, there is this. There is the Roassal3 documentation. We have like GitHub. We have tutorials, for example, this one. This is a tutorial where you can see how you can play with the Les Miserables, the data set from the book. Les Miserables, and you can start to play. And we have plenty of tutorials. More will come. We will have again. We will have a book that will hopefully next year will be out. So documentation, something we didn't pay attention to. The documentation is coming. It is really coming. We'll push very hard on the documentation. Now we are pretty happy with we're pretty happy with the way that the code base and the documentation, yes, is something we will come. Here are another example. Okay, so someone asked, is there any help you need from the community? That is a tough question. Yes, okay, so I will be very open here. So to reach the level that we have with Roassal3, I do have to pay full-time engineers. I do pay full, for example, Milton, one of the main authors of Roassal, so I'm paying him full-time. He's an engineer working with me for more than 6-7 years already. And yes, so finance is something where maybe the community can help on that, in the sense that we've been doing some project for companies in building visualization. So there is building the visualization and also evaluating the visualization. As has been said earlier in the chat, designing a visualization is very hard. It's very hard. For example, like that one, it looks extremely simple. We are visualizing the flight software of the Chilean satellite. Here we're visualizing the flight software of the NASA, the NASA flight software. Why we did it that way? I mean, we did a lot of prototypes before, so there is a whole phase on how to design it and how to evaluate it, and something where we have really a lot of experience in. And so yes, so the one way to help us, to help Roassal, is really if a company is ready to benefit from our experience, we'll be very happy to talk to. Because at the end of the month there is salary that need to be paid, and yes, so I take care extremely on them, and so yes, so funding is a big important topic. Yes, so there's been like whether there is a way to do some diagram editors, such as UML, BMP. Yes, that would be super cool, and that should be pretty easy, pretty straightforward to actually achieve that. Yes, that should be pretty. I mean, hopefully after the book, after the second edition of Agile Visualization, we will work on that. Like we will work on that. I mean, we believe that Roassal3 will be stable very soon. It's very stable. So then, at some point, the way to continue to work on Roassal is to build things on top of, and have graphical editors is something that would really make sense. Yes, so I mean, if you guys have yes, I mean, I see that people are motivated in writing a graphical editor, so please let us know. I will be happy to help to guide on that. Okay. So thank you very much. If there are more questions, I will be happy to answer. I think I've been talking like for more than 1 hour, so 1 hour. Sorry, I think it was very long.
I have a question. I have a question, which is not really for Alexandre, but more in general for everyone. Do we know if there is any way, any sort of bridge interface between Faro or any other Smalltalk dialect and the R language?
There's an R bridge.
Is there an R bridge? I'm asking. I'm not saying that there is. I'm asking if anyone knows of any, because you can do fairly complex statistical calculations using R, and it would be good to be able to integrate that with Roassal to visualize the results.
we don't have we do not have experience with R, but we do have experience with Python. So we build reach with Python because Python has an incredible number of libraries, and maybe I can show here.
Sorry, Alexander, you're sounding very, very far away at the moment.
But actually, physically, I am. But,
yes, you are. But not for Zoom. Now it's better though.
Yeah, because I think I was loading something on the web. Okay, so here, we build the Python bridge, talk to Python from Smalltalk, and the Smalltalk way. So it means that there is some videos, and we have ways to actually build the HT with a Smalltalk, but you can hide that within a facade, and then boom, this is sent to Python. So basically, you can really talk to Python. So here, this is a tutorial on how to use OpenCV from Smalltalk. This is you're really using the OpenCV Python modules. So yes, so basically you will have to do things like that, but then at some point, yes. So this is what here is, and that works also for VisualWorks. Huh? Some people actually in California are actually using that. And we've been, because the idea was to use to do some artificial intelligence things in Python, and to use that within Smalltalk. So with R, no, but with Python, we do have something. I know that there is a bridge with JavaScript. Maybe, I don't know.